Section 9.2, ANOVA for regression, video 8. Standard error for the slope. In other words, the SE for the explanatory variable in the regression output. As the author rues on page 597, although we generally rely on technology, there is a formula for the standard error of the slope. So we're going to calculate it and then go back and compare it to the standard error that we were given in the regression output. The formula for the standard error of the slope is the standard deviation of the errors, which we talked about in the previous video, divided by the standard deviation of the sample of observed explanatory values. In other words, the sample standard deviation of the x's, divided by the square root of n minus 1, which you could also call the square root of the total degrees of freedom. So for example, let's go back to the sugars versus calories problem that we did a moment ago. In order to calculate the standard error for the slope, we would need to know the standard deviation of errors, which was the square root of 708, which I have since lost, but it was 26.61. The sample size was 30. Remember, we extracted that from the ANOVA table. Now what we don't have is the standard deviation for all the x values. If this were a test question, I would give you a third set of computer outputs that list some descriptive measures of a data set. In other words, output that says, here's the number of elements, here's their mean, here's their standard deviation. So this would be in a third set of computer outputs. And before the end of the semester, we will see problems where you are given 3 sets of computer outputs. But I went ahead and went in Excel and grabbed the data from a spreadsheet, which was available. And the standard deviation to 4 decimal places is 4.3318. Excuse me, 5.3318. And with that information, we can calculate the standard error for the slope. It would be 26.61 divided by 5.3318 times the square root of 30 minus 1. And if you put that into a calculator, 26.61 divided by 5.3318 and then divided by the square root of 29 to 4 decimal places, I get 0.9268. Now, if you were to go back to the computer output for the regression, I forget which video it was, but it's on page 592, and look up the standard error for sugars, in other words, standard error for the slope, it says 0.9269. So why does mine come out to be 8? Well, honestly, before I filmed this video, I wanted to figure out where the discrepancy came from. And what I found out was the discrepancy came from the fact that I used MSE equals 708. However, if you go back to the original ANOVA table, where it said MSE was 708, if you actually do the calculation, 19,834 divided by 28, MSE is actually 708.3571429. And so had I used that value for MSE, I would have gotten a slightly larger value for the standard deviation of errors, and this would have gone up to 9. I figured it was a rounding issue, but you know me, I had to track it down. So calculating the standard error for slope manually really isn't that difficult if you have the pieces. The hardest piece to get actually is the standard deviation for the x's, at least if you're just doing it with a calculator and not some technology that can just say, here's your standard deviation.